All right, so I'm back. We're going to be talking now about other forms of energy. In addition, from the previous chapter, we had talked about energy derived from combustion, burning stuff. And then we have these alternative energies, one of which is nuclear, and the other then would be solar power. And so we're going to talk about both of these, and we're going to start out by talking about nuclear energy, or in general, at first, I'm going to talk about the demand for energy. We use a humongous amount of energy. If you fly anywhere at night, you can see lights everywhere, and that really sort of illustrates this massive amount of energy that we use. And what are we? We have 7.8 billion people, and the term they use is we consume more than 500 exajoules of energy per year. Just suffice to say, a whole heck of a lot. And what is most of it is from chapter 5, right? It was energy from combustion. And so when we talk about energy, I've mentioned this before, but I'm going to revisit it one final time. Einstein's famous equation, E equals mc squared. And we had said the E stands for energy, and the M is either mass or matter, stuff you can touch. And this C is the speed of light squared. And that's a huge number, by the way. It is a gigantic number. And so basically we have a huge amount of energy that's out there and is available. And so anyway, we have energy equals matter times this gigantic number, which is a constant. And I've mentioned before, I'd said that you put gasoline in the car and drive down the road and the gasoline's gone, but you've been able to use the energy. Now, my question for you is, if you can go matter becomes energy, then obviously energy can become matter, right? So think about it and give me an example if you can, or in your mind, come up with an example of energy becoming matter. I'll pause for a second here. I might have to wait a really long time because you're not going to be able to come up with anything that represents it. So this is a theoretical, but we've never seen it. If we talk about, how the theory for how the universe was created, it's energy becoming matter. And you may have heard of the super collider in CERN over in Europe. It's on the border between France and Switzerland, or somewhere over there. And basically what they're doing is they're bombarding particles together. And you might say, well, why would you do that? They're trying to create mass. That is the whole reason. It's a theory. The theory, they're trying to see if Einstein was correct. All right, so we have all of this energy that we're using. We're using a huge amount of energy. And most of it is coming from ancient photosynthesis. And we had said that we're running out of that. I mean, at some point, we do keep finding new sources, but there is a finite, a limited amount of that is available to us. So that's why we have things like nuclear energy. And so nuclear technology has been around for quite a while. So in 1938, there were these two German scientists, Otto Hahn and Fritz Strassmann, And what they did is they bombarded uranium-238. We'll talk about what that means in a later video. They bombarded uranium and somehow got barium. What? How does that work? And so they were scratching their heads. They couldn't figure it out. So they asked a colleague of them, Lise Meitner. Your book talks about this woman. And so she got to looking at it, and she realized that what happened is the atom broke in half, or split into approximately two atoms of about half the mass. And so if you think about an atom, and we had said that the number of protons determines the identity of an atom, well, what they had is they went from an atom that had 92 protons to two different atoms. One of them I was trying to find, it's barium and krypton, I guess. So barium has 56 protons, and krypton has 36, and so and that's from 92. And so what they discovered is fission, nuclear fission. Fission means breaking in half, or breaking is what it really means. And as a result of this, the two scientists that did the experiment, they couldn't figure it out, but this Meitner woman did. And so what they did is she ended up having an element named for her. And so if you're a physicist, that's a heck of an honor. She has, she had published this in Nature, her idea that that the breaking apart also released a whole lot of energy. So, because remember, in the last chapter, we were talking about the second law of thermodynamics. And in the second law of thermodynamics, we had said that there is no energy transfer, that no reaction that doesn't release a lot of energy. And so in this reaction, it releases a lot of energy. And so she ended up getting an element named for her. Woohoo! And so this discovery is what has led to nuclear power plants, nuclear fission, breaking the uranium molecule into two other molecules, two different. The atom literally converts from one thing into two other things. All right, we'll stop right here.